Hello everyone. In this video we're going to be computing an indefinite integral. So we have the integral of dx divided by the square root of x plus the cube root of x, and we're going to be using substitution here. You know that the U substitution is very powerful while computing integrals, and this is one of these. And what we're going to do here is we're going to consider two radicals here. We have the cube root, we have the square root. So I'm thinking about 2 and 3. And I'm thinking about their least common multiple. The least common multiple of 2 and 3 is going to be 6. So I would like to replace x with something like this. X equals u to the power 6. In other words, I'm basically saying that u is equal to the 6th root of x. Okay? Now, what happens if you replace x with u to the 6th? You're going to get some nice expressions from here. But more importantly, let's go ahead and calculate dx first. So if you differentiate both sides here, you know how to find dx, hopefully. You're going to differentiate u to the 6th. That's going to be 6u to the 5th multiplied by du. So what I'd like to do is I'm going to make the replacements and then see what we get from there. And this is going to be a really interesting integral to solve. So what about square root of x? Well, if you square root x, you're going to be getting basically u cubed. And if you cube root x, you're going to be getting u squared. All right, great. Now, let's go ahead and replace the expressions with those, and let's see what we get from here. So we have the dx. dx will be replaced with this. So let me show you here. This is what dx is equal to, and then I'll make the other replacements as well. So let's write our integral one more time. The integral of dx divided by, I have the square root of x plus the cube root of x, okay? So I have square root of x plus cube root of x. So dx will be replaced with 6u to the 5th du, and square root of x is equal to u cubed, and the cube root of x can be written as u squared, and we have the integral. Now, u substitution is super powerful because it kind of turns a difficult integral into an easier one. Now, notice that here we can factor out u squared at the bottom. So let's go ahead and do that and write it like this. So if we pull out a u squared, you're going to have u plus 1 left, right? And we have, let's take the du outside. Okay, now I can definitely go ahead and, cross cancel some stuff here. For example, u squared goes into u to the 5th, u cubed times, and you can pull the 6 outside. So we have the following. 6 times the integral of u cubed over u plus 1 du. Now, a lot of people are going to use partial fractions, long division, synthetic division, whatever you want to call it. But let's go ahead and take advantage of algebra. Can you turn u cubed into something that is factorable and also something that contains u plus 1 as a factor? And it's quite possible because we know that from sum of two cubes, u cubed plus 1 can be factored into u plus 1 times something else. But where does that 1 come from? Well, you can add and subtract stuff, so let's go ahead and do that. 6 times the integral of u cubed. So what I'd like to do is add 1 and then subtract 1. All right, cool. So it's balanced out. And then what I'd like to do at this point is obviously separate these into two expressions. So I can write it like this. 6 times the quantity, the integral of u cubed plus 1 over u plus 1. And you don't really have to separate them into two integrals. You can just do it underneath one. Okay, cool. Just like this. Great. Now, what are we going to do next? We're going to factor u cubed plus 1. And we can write it as u plus 1 times u squared minus u plus 1. Remember, from sum of two cubes, you can factor it. And obviously, u plus 1 is going to cancel out in this case. And we're going to end up with a nice expression. All right, great. Now, what can I do? I can just go ahead and get rid of the u plus 1, and I'll end up with a polynomial expression. Let's go ahead and rewrite it to see better. We have u squared minus u plus 1 minus 1 over u plus 1. Okay, you could also find the same answer by using, polynomial division, long division, or synthetic division as well. As long as the divisor is something like u plus a, you can do that. Now, what am I going to do with this? Just integrate. And of course, the 6 is going to stay on the outside and will be multiplied by everything. And then we'll back substitute. Okay, let's go ahead and integrate this expression, which is fairly easy to do. So it's going to be 6 times the quantity. Now, if you integrate u squared, remember the power rule? What was the power rule? Well, if you have u to the power n du, you can basically write it as u to the power n plus 1 divided by n plus 1. And don't forget the constant, right? Okay. Now, we're going to use that formula here, u cubed over 3, and then minus u squared over 2, plus the integral of 1 is just u itself. And then this expression right here is going to be the ln, because it's like 1 over u, but with the addition of a constant, it wouldn't really make a huge difference. So you can basically write it as ln of u plus 1. Now, I'm supposed to use the absolute value here. Let me go ahead and use it, because we don't know if u is going to be, or u plus 1 is going to be positive or negative in that interval. We don't even have an interval, by the way. So this is kind of indefinite. And at the end, I'm going to place my constant. Okay, that's pretty much the answer, but let's go ahead and back substitute. So what is u cubed equal to? What is u squared equal to? If you remember, we said that the 6th root, right? The 6th root was replaced with u, right? So u is equal to the 6th root of x. But in my expression, I basically have x equals u to the 6th power, right? So x equals u to the 6th. Let's go ahead and write it down here. X equals u to the 6th, which means u can be written as the 6th root of x. Okay. Now, what am I going to do with this? I'm just going to replace the expressions as with this stuff. So what is u cubed? Now, you can look at it two different ways. You can go ahead and cube this and get the answer from there, or you can just go ahead and square root both sides here, and then you'll get the answer as well. So u cubed over 3, to keep a long story short, is going to be the square root of x, and that divided by 3. U squared, on the other hand, is going to be the cube root of x divided by 2, and then plus u will be replaced with the 6th root of x, and then minus ln absolute value of u plus 1. Now notice that the 6th root of x is going to be positive or non-negative. When you add 1, it's definitely going to be a positive quantity, so I don't need absolute value here. I can just go ahead and write it like this, and that's going to basically conclude my solution. All right, so that brings us to the end of this video. I hope you enjoyed the video. Please like, comment, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.